Hello. So in this video, we're going to take a look at the type system, specifically around three functions: typeof, isa, and fits. And we're going to talk a little bit about structural typing versus nominal typing. And these are really critical concepts to understand in order to make use of the validation framework, which is entirely built around this notion of the type system. So we're going to go ahead and enter our shell. And the first thing we're going to do is we're going to take a look at the typeof function. So typeof basically takes a data value and it returns the closest fit type for it. So if we say, what's the type of a string, we're going to get back string. And if we say, what's the type of a number, we're going to get back a number. Now, if we look at the collection types, okay, so any sort of dictionary is just going to come back as dictionary. But we could actually put some tags in here that might make it seem like it is a more specific type of dictionary, such as a VAV here, okay? But you see it still comes back dictionary. And that's because in Haystack, dictionaries are generic. They just carry around a set of tags without any specific type attached to them. Now, they do have marker tags, and we can use structural typing to map marker tags to explicit types. So we're going to take a look at that in a second. So typeof, once again, just taking a data value and returning a type. Okay, let's look at the next function, which is called isa. So isa. And the isa is the function for checking things by the nominal types. And what we mean by nominal types is that every type is explicitly declared to be a subtype of another. So for example, if we say, let's go to the entire sys library here. So the top type, okay, is object here. Okay, everything subtypes from object. It's the root type. Okay, and then we have the bottom type none, which we may talk about a little bit later. And then everything else is a subtype of scalar or sequence. So scalars are all of our atomic types. Markers, booleans, numbers, etc. And then our collection types all going to subtype from sequence. Okay. Likewise, if we were to look at what's the type of VAV, you can see he subtypes from air terminal unit. And if we look at that guy, we can see he's a subtype of equipment. Equipment's a subtype of entity. Entity is a subtype of dictionary. Okay, so once again, there's sort of this explicit taxonomy by names. Okay, so when we use the isa function, we're checking whether there's that explicit subtype through the naming conventions. Okay, so if I say, is entity a subtype of dictionary? Yes, it is. Is VAV a subtype of equipment? Yes, it is. Is it a type of point? No. Is it a type of string? No. Okay. So all we're doing basically is basically looking up that type name and saying, is the type on the left explicitly a subtype through that taxonomy tree of the type on the right? Okay. And that's what we call nominal typing. Okay, because it's by name. So we can also pass a data value to isa. So I can say, is a string literal? The type string, it is. Is it a type number? No, it's not. Likewise, I can say, is that a type dictionary? That sure is. Is it a type of list? No, it's not, etc. Okay, so that's what we're doing is we're basically this, okay, is essentially just get the type of that value and that string, and then we're saying is string a type of number, which is the same thing as this. Okay, so once again, isa is basically checking for those explicit types through names. Now let's go back to the dictionary example here, okay, which is a dictionary with a type of equipment, and it's not. Okay, because dictionaries don't carry their type. Now, it is a type dictionary, okay, but all dictionaries in Haystack are just generically dict. They're not assigned to any particular type. Okay, and this is where the structural type system comes into effect. Okay, so the structural type system, instead of matching things explicitly by name, looks at the structure of that dictionary and checks whether it matches the structure of a dictionary type definition. So for this example, I've got a little library here called play, and I've got this very simple type called person. Okay, that I've used in a lot of my presentations. So we can see that person is a type of dictionary, and it defines a required marker tag called person, a display tag called string, a bday of type date, and an optional job field, which is of type string. That's that little question mark is the maybe type. Okay, and in type parlance, we're going to call these slots. In dictionaries, we call them tags. Same thing. So if I have a dictionary that matches this, and I'm going to create this person Alice, who was born at the millennium, and I'm going to say is a person, okay, it's false, okay, because we haven't explicitly typed it as a person. However, structurally, it fits the person type, so we'll return true. Okay, so the difference is here, because it's just a generic dictionary, it's not explicitly a subtype of the person type. However, structurally, with the fits function, it is. Okay, so that's because the person defined these fixed set of tags, and the dictionary I pass the fixed function matches it exactly. Now let's say we pass this as a string instead of a date. Okay, well now all of a sudden that dictionary doesn't fit that dictionary type anymore. Okay, it's not a person because bday is supposed to be a date, not a string. Now, this is where the function called lintFits can be used. Okay, so basically if we just change this from fits to lintFits, okay, now we're going to get an explanation about why it doesn't fit. Okay, and of course here we're saying, no, it doesn't fit the person type because the bday is expected to be a date and you passed me a string. Okay, likewise, let's say display was a number here. I'm actually going to get two different error messages. So I'm actually going to get 0 or more lines with all of the different errors about why this particular dictionary doesn't fit that type. Okay, in this case, I've got 2 errors. If I had 0 errors, then I'm going to get back an empty grid. Okay, so let's go back and fix some of these. So I'm going to actually make that a proper date, and I'm going to give Alice now as a string. And you can see back I get back the empty grid, which basically means the same thing as fits. The empty grid is fits means true. It does fit. Now, I could also take bday off. Let's just rename this to something else. And you're going to see now I'm missing that as a required slot. But now we're going to go back to fits. So let's take a look at our person about that job field here. So job is an optional string. And this maybe means it's okay if you don't have this field in your dictionary. Okay. However, if you do put it in there, it has to be a string. So if I say job and I add it as a number, okay, I now have now I don't fit anymore. Okay, because job was supposed to be a string and I passed a number. Now if I actually do add job and make it a string, let's make her a plumber. Now all of a sudden we fit. And if I just change that to fits, I'll evaluate that to true instead of the grid, which explains why it doesn't fit. Okay, so these are really important concepts to understand the notion of the nominal type system and the structural type system. So once again, isa is the function that's going to test for nominal types, and fits is going to test for structural types. Now everything we're going to do in terms of haystack data validation is going to be based on fits. And that's because essentially we have an infinite number of types that we're matching against the structural definitions of combinations of marker tags. So it's sort of a perfect way to validate our haystack data. And that's all for this one.